outline this soon. Okay, so let's go ahead and start your session today. So this is basically not a new lecture, really. It's PW231. And this is the theory portion. Remember, you have to follow what Professor Jovan says for the lab portion. So in week 5, we're going to review a few worked examples. For soil, for porosity, soil, weight, mass. And then you're going to work on the first half of assignment 1. You don't have to submit it yet, but I think you should work on the first half of assignment 1. We'll also take a look at, what assessments, the assessment schedule, just to make sure you're on the right one. But in essence, we are well on track. We really don't need to do much in terms of the lecture. We've gotten to the point where we need to. But what we need from you guys is, let me see, I've got a few comments here. Okay, all right, good evening, Aiden. So what we need to do is, let me open up. So you are going to work on this assignment this week. And what you want to do is you want to be able to complete part 1. So it's due on Sunday, October the 12th. And at this stage, you only need to solve problem 1 and problem 2. And what I would suggest is you email problem 1 and problem 2 to me once you think it's done to make sure you get it right. If you don't email it to me and you don't think you want to email it to me and you submit it, later on after we're working on problem 3 and 4, that's up to you. That's what I recommend. Work on assignment 1 today, this week. Questions 1 and 2. Finish these. We've covered significant content or enough content so that you should be able to solve these. And let's see. So here's your assessment schedule. Test number 1 will be on the 27th. Interestingly, that's the same date as for the legislation class. So what I'll probably do is I'll probably leave it open for you guys for the whole day so that you guys can get both tests in, right? But before that, you need to focus on assignment number 1. So for that, let's go back to review. Okay, let's go through these slides. That should give you an idea of how to, let's give you a bit of a review. So remember, we can make a chart that looks like is we've got volume on the left-hand side, mass on the right-hand side. It's important that the key factors here for the mass is the soil particles. And we know we've got air and we've got water as well as which is a part of soil. So the bulk soil chart or the phase diagram includes air, water, and soil. This is what a phase diagram looks like. On the left-hand side, you put down the volume. So you've got the volume of air, which you calculate, or it's given. You've got the volume of water, which you calculate, or it's given. And then you have the volume of soil. Right? Remember, porosity is going to help us with this. And then you on the right-hand side, you put mass or weight. Get the mass of air or weight of air, which is going to be 0 for all intents and purposes. And then you've got a mass and weight of water, and then you've got the mass and weight of solids. Remember, unit weight is equal to the force or weight over 1 unit of volume. And the wet unit weight of soil is given as the wet weight over the volume. The total weight. You can also calculate the dry weight when you deduct. When you deduct the weight of the water. Another important thing to keep in mind. So the soil density, rho, is mass per unit volume. The wet density of the soil sample is equal to rho wet is equal to mass total over the total volume. And then you can get the dry soil mass over the total volume. That's the dry density. Now the water content is given as the weight of the water in a soil sample over the weight of dry soil, the solids. The percentage of water is the weight of the water over the weight of the solids times 100. That is the water content, and it's expressed as a percentage. So you want to be able to use these formulas. And it's basically the relationship of the water content, the relationship of the dry soil, and the total weight of the soil volume is what helps us assess the phases of materials. And helps us create the phase diagram. We can take the percentage water content and manipulate it so that we can get the water weight or the total. You can include the total as well in this. So the water is equal to the mass of the water and soil volume over the mass of dry solids. That's the water content, and you multiply it by 100 because it's expressed as a percentage. Okay. And you can, again, manipulate the same like you did with the weight. For the mass, you can manipulate it so that you can get a relationship with the the mass of the soil, and the total mass, and the percentage water content. So the void ratio is E, and it's the volume of the voids over the volume of the solids. Then you've got a concept of the porosity. It is the volume of the voids over the total volume times 100. So you need to be careful and remember there's a difference between the two, between the volume of the voids and the volume of the solids. Sorry, the void ratio, which you get by the ratio of the volume of the voids over the volume of the solids, and the percentage porosity. It's the volume of the voids over the total volume times 100. And then you've got the relationship between the void ratio E and the porosity N. and calculate that as well. Remember, E is equal to V volume of the voids over volume of the solids. And you can replace that. And you end up with E is equal to porosity over 100% over 1 minus porosity over 100%. Remember these formulas. Okay? So that'll help you. The degree of saturation is a volume of water over the total volume. And it's also expressed as a percentage multiplied by 100. So when a soil is 100% saturated, it just means that the voids are full of water. And that's usually the groundwater table, or below that, the groundwater table. So let's take a look at an example. Pay close attention. So a sample of soil obtained from a test pit is 0.0283 cubic meters in volume. It has a mass of 63.56 kilograms. The entire sample is dried in an oven and found to have a mass of 56.75 kilograms. The difference would be the mass of water. Calculate the water content, wet density, and dry density. Okay. So think about this question for a minute or two, and then we will attempt it together. So what I would recommend is first drawing out the phase diagram, the basis for the phase diagram. Okay, so for the question here, where's the lecture posted? Okay, so all right. Let's go ahead and find that for you just in case any of you is having trouble finding it. Peter seemed to not know where it is. It's not in week number 5. There's no lecture in week number 5. This lecture was posted. It's a review. We went through this last week. So if you go to week number 4, theory, you should find the lecture here. And you should see the slides here. So this is where we got to. Are you clear on that, Peter? Yeah, it's in the last week. So I see why you were confused with that. Okay, all right. That's okay. At least you got it now. So whoever is watching this lecture will know where to find it. Okay, so let's get back to the slides. Okay, so it's important that you guys understand how this is done. Here we gotten to this point. Okay, so the next thing you're going to do is determine, so you know what the mass of the dry soil is, right? It's right here. Hopefully you can see my cursor. You know what the mass of water is. You just deduct the mass of the uh, dry soil from the total. That's the mass of the water. The volume of the sample is given is 0.0283. So the wet density, all you need to do is take the mass, the total mass, divided by the total volume. That'll give you the wet density. And then the dry density is the dry mass divided by the total volume. Then what you do is you take the mass of the water, you divide it by the mass of the soil, multiply by 100. So it's 6.81 divided by 56.75 times 100. That's the water content. Let's take a look at this question here. So a 1 cubic foot sample of undisturbed soil is found to have a dry weight of 107 pounds. If the specific gravity of the soil solids is 2.7, what is the void ratio of the sample and what is the porosity? So for this example, it's a little more challenging. So let's go with the start. The phase diagram, and remember, we were given the specific gravity, and you're going to realize why we need to use the specific gravity. So the volume is 1 cubic foot. It's given on the left-hand side. And we got the water of the solid. So not the water, the weight of the solid. 107 pounds. That's the dry weight. That's why we know it's the weight of the solid. So this is a good starting point, the phase diagram. And I want to stop here and reiterate what this is, because you want to be comfortable with this. You want to draw it, right? It's going to be the air, it's going to be the water, and the solids, or the liquid. In this case, is water. On this side, you want to have the volume. This side, you want to have the mass. Okay, so this is key. This is when you fill in the information on the left and right hand side. This is known as the soil phase diagram. That clear? Anybody have any questions about that? Of course, many of you are not in attendance, so you might have questions later, but even if you don't right now. Just a reminder, we're going through this review so that you can attempt the first part of the assignment for this week. Okay, so let's get into the solution. So the weight of the solids in the according to the formula is equal to volume of the solids multiplied by let's make sure I understand this. The gravity of the solids, specific gravity of the solids, times the unit weight of water. And because we're not working in SI units, the numbers are going to look a little bit odd, like the unit weight of water. It's 62.4 pounds per cubic feet. And the weight of the solids is going to be in pounds, and the volume in cubic feet. Remember, we're dealing in this question with SI units. Start to fill stuff in. And here are the formulas that you're going to use to determine the weight of the solids. You're going to use this formula to determine the volumes. And we know the total volume. We want to determine the volume of the air and liquid and the volume of the solids. So the first formula you're going to use in this question is determine the volume of the solids. You're going to plug in the weight of the solids, which was given, the specific gravity of the solids, 2.7, and the specific weight of water is 62.4. Your volume will be 0.636 cubic feet. Step 2, you take the volume of the voids, or you calculate the volume of the voids by deducting the volume of the solids from the total volume. Step 3, you can get the void ratio now by taking the volume of the voids, which is the volume of the air and the liquid, divide that by the volume of the solid. You get your answer 0.57. Similarly, you take the volume of the voids divided by the total volume, and you multiply it by 100. That is your porosity, 36%. So that will be how you solve that. So let's take a look at this question. We've got a volume of undisturbed soil is 0.015 cubic meters. So that's the total volume. It has a wet mass of 31 kilograms. That is the total mass. It has a dry mass of 27.5 kilograms. So if you deduct that from 31, that will give you the water, the mass of the water. Specific gravity of the solids is 2.71. So first you want to determine the void ratio, and then the water content, as well as the degree of saturation for the in-place condition. So here are the formulas you're going to use for the solution. Just remember, this is for the solid mass. This is for the volume of the solids, specific gravity, the density of water. Here you've got the mass total. Here's the mass solids. Here's the mass of the water. Here you've got the volume total, the volume of the solids, and the volume of the voids. The saturation percentage is the volume of the water divided by the total volume. Sorry, well, divided by the volume of the voids multiplied by n. So let's get to it. So step 1, you want to determine the volume of the solids. So it's equal to the mass of the solid divided by specific gravity times the specific density of water, which is equal to 27.5 divided by 2.71 multiplied by 1,000. Here's the volume of the solid. Step 2, if you want to calculate the volume of the voids, you take the total volume and you deduct the volume of the solids. So that'll be 0.015 cubic meters minus 0.01015 cubic meters. And you've got your answer is 0.00485 cubic meters. We can then calculate the void ratio, which is then going to be equal to the volume of the voids divided by the volume of the solids. Which should give you the answer. So let's go ahead and calculate that. I think I'm gonna get, let's see. I'm gonna give you guys the answer to that. 0.048500485 divided by 0.01015. That's 47.78%. That is the weight ratios. Water content. So first you want to find the mass of the water and divide that by the mass of the solids and multiply that by 100. That will give you the water content. Step 4, we calculate the volume of the water. So the volume of the water is going to be equal to the mass of the water divided by the specific weight of water, which is 1, multiplied by 1,000, which is the density of the water. It's 3.5 divided by 1,000. It's 0.0035 cubic meters. Degree of saturation is going to be the volume of the water divided by the volume of the voids multiplied by 100. So that is 0.0035 divided by 0.00485 times 100. And it gives you the water of the degree of saturation in a percentage. Okay, so that is that for you guys to, hopefully it will give you enough for you to work on assignment number 1. So let's take a look at assignment number 1. Question number 1. I'm hoping you can do questions 1 and 2 this week. Here's the first question. A moist soil has a volume of 0.3 cubic meters and a mass 560.7 kilograms. After drying, the mass of the soil is 500 kilograms. The specific gravity is 2.74. Calculate the soil water content, that's the percentage of water, the wet density and the dry density, void ratio, porosity, degree of saturation. Show all your calculations and draw your phase diagram with given and calculated values for masses and volumes. Okay, so that's the first question. And to me, it's quite obvious that based on the examples we looked at today, you should be able to solve this. And for the second problem, so the porosity is 0.33 or 33%. The specific gravity of solids is given as 2.8. The soil water content is 11.5%. If the volume of the voids is numerically equal to the void ratio, find the dry and wet density, show all your calculations, and draw a phase diagram, should be, with given and calculated values for masses and volumes. Okay. So that is my review for this week. So for this week, what you need to do is you need to work on assignment 1, questions 1 and 2. And next week. So next week we will have a lecture, but if you can drop by towards the end of the lecture or sometime during the lecture and ask me if you need any help, I'll be here to help you. Otherwise, I'm still here for another hour or so to help you with this one, those of you who are in attendance. For the others, the way I recommend that you go about this who are not in attendance, this is what I recommend for you guys. So use my review lecture today. Use my review lecture with the solutions, with the solved examples. To work on assignment 1, questions 1 and 2. You should be able to do all right. And if you have issues, if you have questions, bring your questions to this live recording session Monday. If this time doesn't work, schedule a different time with him. Monday morning, I can also work with you, or Monday afternoon. But Monday probably works best for me next week, or I'm on campus next week, Tuesday. Okay, so I'm going to end the recording here. That is all for today's recorded portion of the lecture, but the Zoom session will remain open for those of you who are in attendance who want to work on the assignment. And the